Alright, so I went ahead and attached a 4.7K in series with a 2.2K. I'm going to go ahead and plug this in. It's obviously all the way down because we have 0 volts here. We're going to go ahead and turn it up. You start to see that Triac waveform there. And as we increase it, increase the current, it's at about 5 milliamps right now. Keep it going all the way up. You can actually hear it winding up a little bit. We're at 15 milliamps, which is a little more than I'd like to be at, but not bad. We're at 119.5 volts, so that's basically line voltage. I'll go ahead and stick this meter into the wall when we're done and make sure that we're as close as possible to that, but I'll bet it's going to be about 120.3. That's what it's been in the past. So with 2.2K and a 4.7K to give you a total of 6.9K in that original circuit. Take a look at this again. So we have 6.9K there. That's our current of 15.53 milliamps. This capacitor we up to 0.3 microfarads. That's the DB3 Diac, the Triac, and a 25 watt load. Now this Triac is actually rated for 8 amps. So I'm going to go ahead and plug it into an inductive load, a jigsaw to be exact, and we're going to see what that waveform does. Now, we all know you shouldn't run ceiling fans with Triacs because of the voltage and the current. When the voltage drops significantly, the current can't immediately stop, so the current actually continues to flow. So we're going to go ahead and plug this in, and I'm going to show you a little bit of that. Alright, I went ahead and hooked up this is my jigsaw over on the right here. So I have it turned on to high. It'll draw 3 amps, so not huge, but it'll give a little more load than that 25 watt light bulb. So I'm going to go ahead and plug this in, and we're going to see voltage jumps a little bit. We're going to go ahead and up this. You can hear it whining there as it wants to start. You see the waveform there. Now you see that little peak that dips down below 0? That's going to be because it's an inductive load, and the current can't immediately switch. So as you can see, we have a variable scroll saw now. This only has an on and off switch. So as we go ahead and turn this up, again, you see that dropping down a little bit, and that's because of that inductive load. Alright, that went all the way up, and as you can see, the waveform wasn't totally full, but we got up there close to mains voltage. And that thing was running at full power, so the Triac seemed to handle it with no problem. So, hope this helped you. Questions, comments, just let me know, and I'll be happy to answer any questions I can. Almost forgot. I told you guys I was going to stick the probes in a light socket, see what we get for line voltage. Let's put it on auto there. It's going to be 122.2, so we were getting 119.5, not bad. So that's about 2.7 volts, 2.8. So with the increase in current needed to get that full 122.2 volts, it's really not worth it because you'd have to increase the rating of your resistors or do multiple resistors in series to divide that power dissipation across multiple resistors. So the other thing I'm going to show you real quick is how to test which one's line voltage. So all you have to do, stick that in there, and we're getting 0.7 volts RMS, which is close enough to 0. So I'm going to go ahead and take that, put it in this one, and sure enough, there's 122.6 volts. Now, theoretically, in a perfect world, the larger of the two plugs would be the neutral every time. But with people doing their own wiring and stuff, you just never know what you're going to find. So again, I'd prefer to stick the 2 meters in. We get 122 on that one, and then on the other one, 0.7 or 0.